So today we're going to be looking at the charging system and just kind of figuring out what else we need to get that set up. So you can see here's the the gas filler where the gas filler used to be, and we got a spot here, and we got some room down underneath for the cables. So what'll probably happen is we'll put an inlet on here. Maybe I'm not sure if we're going to do 1772 or not. We may just put a marine style inlet. Something that's good up to, I think the chargers are planning on about 40 amps input, so at 220. So, maybe some sort of marine style inlet there. Probably run it under the vehicle and then up into the back. And we were sort of planning on putting the chargers up in there, and we have a bracket that was made previously. So these are Zyvan NG3 chargers, and these ones are specifically the 96 cell, 90 amp hour, which that's about right. And yeah, you can see they pull about 20 amps on 208. So obviously we have two of these chargers, and the bracket that was made previously, it's got these studs here and here, and that mounts into, I think there's, you can kind of see that hole right there, and there's another hole over there. So it basically mounts underneath where those cables come through, and then it presents the high voltage output on towards the back of the vehicle. So I think that's what we're going to do. We'll make a custom cable that connects the AC input, which will probably come up through here, and maybe a junction box or something just to keep stuff clean, and then go back there. And the nice thing about these chargers is they're pretty easy to pop open, and you can change out the service cord that's on them. So we'll make something that makes this sort of modular in case it ever needs to get pulled out, and then it gets tucked away in a pretty nice spot that's sort of out of the elements, isn't going to get splashed on or anything like that. Okay, so we got these two chargers in here. It's pretty tight, but it's not unusable. And those studs that I was talking about earlier are sort of visible, in the back there. It'll be a bit of a reach, but you'll still be able to tighten those down. So I think that's the plan, is we're going to use these Zyvan chargers, and I got a good picture of the connector for the status symbol, although you can see the status LEDs from here. So the idea is that we're going to have, there's a connector in here that basically will mimic the status LED there, and then we can run that into the cab or out the back to an LED or something, so that you can see the charging status without having to pop this service hatch. So I think those are going to live there. We'll probably bring stuff down to a power distribution box that might live here somewhere. That just seems sort of like the spot to be. And then I think over here we're going to reserve that spot for the radiator and fan, sort of sitting in here facing sort of like that, so it gets a little bit of airflow, and I mean there's also a fan on it, so it shouldn't be too bad. And then putting the DC-DC converter somewhere in here. So we are back today. We're working on the DOKA. Had to take a few days off. We had some really bad wildfires here in Oregon, and that basically made it impossible to go outside. It was just so smoky, and you couldn't breathe, after a few minutes. It was just a bad time to be outside. So I stayed in, worked on some of the stuff that so we can make some progress on the DOKA. And I have a lot of parts that came in and that just are ready for assembly. So let's talk about a few things here. So this frame that holds the two chargers, the two Z-Van chargers, I took it out and I placed, I added some more brackets onto it. So I just welded, these are angle iron. Actually, they're old, bed frame material. It's just, what we had laying around. And cut those up, and I welded in some screws into here. So those are just M6 screws. And that will hold the high voltage power distribution box. So I'll put up on the screen a rendering of what it'll look like, but it'll also have a 12 volt little fuse box that'll hold a few relays and fuses, and it'll probably end up holding our Microplex MRS box. So that'll do a couple things for us. For one, it'll let us kind of control the cooling situation a little bit better. We'll be able to read the temperature over CAN from the inverter and from the DC-DC converter, and kind of do a smart control of when the fan turns on. And that's another thing that we got in recently is, well, we didn't get it in, but I picked it up from a friend of mine. This is a radiator. I want to say it's out of like a Ninja 250 or something, small motorcycle, and it's kind of the perfect size for a lot of conversions. It's small, it's got a brush guard already, which is pretty sweet, and a fan, and a filler neck, and an inlet and an outlet, and this should be just about perfect for us. And I think the plan is we have an electric pump that will run basically whenever the vehicle's on, and so it'll be running through the radiator, and we'll get a little bit of airflow from where we're going to put it, and then we can decide whether we want to turn the fan on or off to get additional cooling. So this will sit somewhere in here, sort of at a bit more of an angle, and so the filler cap will be accessible, and everything will it'll kind of make sense. There should be enough room up there to get some airflow through, not be blocked too much. So we're going to do sort of a smart control with that. 2-stage, pump running and then fan running. So we'll need to make another bracket to mount this to. It's got some kind of bushing things top and bottom, and that'll probably tie into this frame member and maybe something up here, and that'll also hold the DC-DC probably. Still trying to figure that out. This build, the power distribution box, will be kind of its own build, and it'll be kind of self-contained in a few ways, but one of those is that it'll just basically connect to these two high voltage lines. Those will go through some glands up top, and then the high voltage lines from the charger, or from the inverter, will go into a couple glands on the side here. So it should be fairly straightforward. And then there's a couple of low voltage connectors that'll go on the side here, now that I see this throttle linkage is in the way. So but they'll go sort of in this area and be pretty accessible for control of the inverter and the vehicle side stuff. So they're basically to be a connector that goes to the inverter harness that controls or has all of the power, and there's a soft start mode that the inverter can run in on its own, and all those connections will be on that connector, and the contactor control will be on that connector as well. And then another connector will be for high current 12 volt to supply all of the 12 volt things that we need, and some logic from the car. So it'll, the ignition and start signals, the brake signal, a few other things. We got a lot of positions on that connector available. So this will kind of be built on the bench, and it'll have a bunch of things screwed into the base of it. And then from here, with the lid off, you'll have access to another large fuse, the small fuses for the chargers and the DC-DCs. The contactor will be right here, and then the cables will come in and kind of land directly on where they go. So there isn't too much disassembly needed if you need to service something in this box. And then the 12-volt fuse box will be in the lid here. So should be a pretty clean setup. So like I was showing earlier, when the throttle was mounted and the way that I mounted the PDU box, it was interfering. Where I was planning on putting connectors on the PDU box, it wouldn't have fit because the throttle had an extra long return spring. The original spring is almost twice as long, and this pop box has a return spring in it already, but I think the extra spring was for, a stiffer pedal feel. So I found another spring that isn't quite as strong, but I think because it is going to stretch more, it's going to definitely feel stronger. And that would allow me to just cut this off here, and then that'll give me room for the PDU. Alright, so I just cut off, about 2 inches of that material, and I replaced the spring, and now where this wasn't able to be used, now I can put my 2 connectors here and here, and those are going to be essentially low voltage connectors, so that the inverter has a place to have its wires plug in, and there'll basically be a couple connectors here, and these are the 13-pin Amphenol, which are pretty nice because you can get there's 2 of the size 12 contacts, so those take up to 12 or 10 gauge wire, and then there are 11 of the size 16. And so basically I'm going to have the 12-volt feed coming into the box through here, and all of the vehicle side connections will happen here. So the ignition and start signals and the brake input and a few other things. I mean, we got plenty of connections here, and then and the outputs for the fan and the coolant pump will also come out of here. And then this 8-pin connector is basically dedicated to the inverter, so that will the contactor control will happen through here, and also power feed to the inverter, and the soft start control that the inverter does with a relay that's in the fuse box. So this is one of those it's a little fuse 60 position fuse box. So this one in particular has a sure latch technology, which is it's basically like you need a tool to get into it. So just a screwdriver to pop the latches open, and there are basically 5 positions this way and 12 positions this way. So it's the same number of pins as like an Eaton RTMR box, but it's configured slightly differently, and they're all configurable. So we'll have the microplex is probably going to go here, and then fit a couple of relays, and then fuses I think are probably going along the bottom. And we have to fit a diode in here for the inverter soft start. So that's just kind of a brief look at how that I/O is going to work. And we got a couple other things that I'll show when we get around to working on the PDM, but it should be a pretty nice compact box. It's just a matter of kind of making sure everything fits in the right place. So I was just editing this video, and I realized that I never had sort of a wrap-up of how the PDU kind of got finished. And it's not totally finished, but at least mechanically it's all done. And I wanted to kind of point out So this is the little fuse box, and this is sort of what it'll look like. These are just sort of placed in here loosely to give an idea. So the microplex will sit here. As you see, it just sort of like plugs in to the fuse box. It looks just like a normal, it looks like two relays put together, basically. So that's going to sit here. The soft start for the inverter needs a relay and a diode. This is a 3 amp Busman diode. And so that basically, that helps just kind of pass power to the inverter at the right time. And then I just put a couple of relays in here with, a bunch of fuses. So there's plenty of room in here, and these can kind of be configured in various ways if I wanted to, put them next to each other or stack. If we remove the lid, you can kind of see how this matches up compared to the drawing. So the high voltage connections will come in here, positive and negative, B minus, B plus, B minus, and then they'll come through and land on their respective studs. And the B plus will also get kind of routed to this side of the fuses. And then these fuses are for the DC and the 2 chargers. So, and then there's a big, chunky 225 amp fuse that goes to the contactor that will go out of this connection to the inverter. And then the negative, B minus side will go through this one and go out this way. So you get kind of your inverter connections here, high voltage input connections here. This is actually a 4-position gland for the chargers. So they'll each have like a 12 gauge wire or something overkill for what they're doing. And those will route kind of under the fuse and go to the negative and then the other side of these fuses. And then there will be another gland here for the DC connection. So like I was telling you guys before, this is basically the vehicle side. It has the high current pins and a bunch of low current pins. And then the other connector is for the inverter. And those wires will come up to the fuse box that'll sit right above it here. And also to the pre-charge, this is a mini tactor, which is overkill, but, pre-charge contactor and control for this contactor line that'll get routed kind of down and away from everything high voltage. And we'll likely put a piece of fish paper or something here to keep the high voltage stuff separate from the low voltage stuff, as well as we'll probably high pot test the wires when we're all said and done, just to make sure that we don't have any sort of connections that we don't want going on in the box. So yeah, I'm pretty pleased with how this turned out. These are all kind of through bolted. So what I'll have to do eventually is pull all these apart, and probably one at a time. And I'm just going to silicone all of those studded connections and around these connectors, maybe. These are pretty nicely in there. I put it in the mill and kind of just mill the hole. So, and then drill a few holes to get the screws in. So maybe I won't silicone around those in case I ever want to remove it. And the idea is that I'll be able to disconnect the pre-charge and disconnect the contactor, unscrew these, and remove it through the hole in the lid. And so it'll be kind of its own harness. But yeah, I just need to go through and silicone stuff. And some of the things like these connections, those go to the Anderson plugs. So this will be kind of permanent. These will be kind of permanent based on the wire length that we figure out. So I'll probably, again, do some silicone around there. And then definitely some silicone around this edge, because we, I basically just milled the hole. And there is enough room on that left side there. It just looks close. But we're going to silicone it anyways. And then all of those connections have wire seals. I have a whole kit of the different pins for the fuse boxes and the appropriate size wire seals, and then anything that doesn't get a wire in it will get a plug. So, I mean, theoretically, you should be able to kind of pour water this way or from the backside, and it won't come through the fuse box. But actually, I don't know if that's true because there's a bunch of holes there. But yeah, so I wanted to give you guys kind of an overview of how this turned out.